Hi, this is Esklunta and welcome to watch this tutorial video where I'm showing that how to implement this, go through this TDD tutorial. I've used this material on multiple courses and now I'm recording this as a screencast that in case you get stuck somewhere here or want to have a reference that okay, how I would implement it, then you can watch these videos. But I recommend that you first try implementing these steps yourself and then afterwards you can watch these videos. Or if you get stuck, like here there's a complicated refactoring, so you might want to get some help. But first we want to, when starting a new project with TDD, the hardest part is usually think that what test to write first. And we are making a Tetris game, and I'm thinking that one core feature is that there are blocks that are falling from top to the bottom. And let's start with just one by one blocks to make it simpler. We don't want to that we can just focus on this one feature at a time. And if we would even further simplify the Tetris game, even the Tetris board, the game area would be a one by one, and then there drops a one by one block, and then you get a full row and it goes away. But that would also include some other features like detecting when a row becomes full and counting the score and other things. So let's just focus on making falling blocks, and then later on we can then implement rotating them and different shapes and so on. Okay, so here is some boilerplate code that for us to get started. And when we run the tests, there should be a test failure in here, and expected that, but the toString printed that. Just sort. And now it's passing. So also passing just like that. So, and this test is that the new board is empty. I will commit these as I go forward. Then let's get the next test. So a new board has no falling blocks is the feature we are implementing, and let's implement it, and we can still check that okay, the test should fail, and so our test framework is working, and our test is testing something, and then we can make the simplest possible implementation that is needed to pass all the current tests. Then now let's work on advancing this. Let's say we drop a block, then what should then happen? Let's create a new class for that. I'm using the characters to represent the colors, and when we drop a block, then there is a falling block. Let's implement these methods. Like that, and then let's see what would be the simplest possible implementation for just changing this. we could put that thing into a field and in here change it true, and it's passing, and there isn't yet anything to refactor, so let's just move forward. Then when a block is dropped, it starts from the top middle. This will drive us to implement showing those blocks. And now let's see. Well, very dirty way of implementing this would be that we just check that if we are on the row 0 and column 1, then we print that. Let's see. Okay, I'm that test I just that this one started passing, but okay, our earlier test this failed because I made a mistake. So let's change it to that. Okay, now it's working. But this code needs some refactoring. Let me just commit this first. Normally I would not commit this often, but I just want to leave a trace for you to follow. Oops. So we have many issues here. Always we want to remove the application and fix bad names. And here we have the application. This X in here and this X in here, they are duplicated. The information about that one is in 2 places, so we want to change that. And we can get it from this block. And we call it the falling block, and yeah. And let's see. Like that. Now we got rid of the duplication of the color of the block. Then we have some other duplication here, like this one, and these two they are duplicating the same thing. We could replace this by checking that the falling block is non-null and also there, and that way we can get rid of that field completely, and we can just call that falling. And this also here is duplicated, and also this doesn't say the intention of what we are doing very well, so those both can be fixed by changing that. I think I will order these a bit differently, like that. Then let's see if we want to fix because we have some magic numbers here. What I'm actually doing here is that I'm checking whether there is a falling block at this coordinates. So if we do it like that, then we raise the abstraction level in here, and this plus thing there is also duplicated. Let's change it like that. And okay, that makes it a bit better. And also this is a magic number. Let's call it's an empty space. Okay, then I think this is all the refactoring that we needed. And let's commit it. Then let's move on to the next feature. When a block is dropped, it moves down 1 row per tick. We have a logical time for the game. Eventually there will be some game loop that will call this every second, or how often it wants to move those blocks. So, but in our tests we don't want to deal with time. We prefer this kind of simple operations. Then let's see. Now it's just staying there. What would be the simplest way to implement this? We want to. This is the row that is changing. So I think if I put that make that into a variable, and then increment it here, then that will make it pass. Now this is also a bit magic number, but maybe we can let's leave it at that for now, and then when we have moving left and right, then we can fix it. Okay. Then just a safety caution. We want to get a error message if we accidentally drop a second block while the previous one is still running there. This how to check that a method throws an exception with just basic JUnit. I think there are better alternatives now that we have lambdas, but I haven't yet updated this tutorial to use them. Okay, but let's see. So it's failing on this line because this is not throwing an exception. So let's see that what was the exception type that it needs to throw. Illegal state exception. And yeah, okay, well, this is getting so ugly, this test, that I think I will refactor this test first to use Java 8 features. Let's create that kind of a method. Like that. Okay, like so. Okay, I think that shows now clearly what we are trying to do here. Okay, expected to throw an exception but did not. Then let's make it throw a, let's say, a runtime exception. Then now it's complaining that we did not throw the right exception, and now let's put an M message. And this assertion is checking only a part of the error string, because because if I just change a word here or there in the error message, it's a cosmetic change. I'm only interested that the reason for the error message is the same, but the exact wording doesn't really matter. Okay, let's move this to a utility class. Okay, so I'm gonna block is dropped, at most one block may be falling at a time. Like so. This is a very simple test utility. So I didn't write any tests for it. I just manually checked that it works when I made the test pass. If it would be in a reusable library, then I would be more careful that all the errors are reported correctly and so on. But that's enough for this application. Okay. This test passed right away. Let's just double check that it should pass. Actually, always when you before you make a test run, you should check that in your mind that are you expecting it to pass or not. So when a block reaches the bottom, we have a setup that okay, we drop a block, then tick 2 times, so it starts there, and after first tick and after second tick it should be there, so it should still be falling there. And actually what we are then interested that then if we tick it one more time, then it stops. So this second one should fail. And it failed because the block moved under the board. Let's fix that. And let's see if we need to check if it's on the last row. We have rows is constant there. I think that's the one. Yeah, now it stops there, but it should. This state is not yet updating. What we need to do is we need to remove it from there. Of course, this would be a simple way to remove it from there, but now this again fails. So what we need to do is that we need to copy the state of this block to be a stationary. We need to make this falling block into a stationary block. And let's see, this requires a bit refactoring, so I will ignore this test for a moment so that we can refactor while we have a green, all tests are passing, and then after that I will come back to this. So I will have a board of stationary blocks which are all originally empty, and then I can copy those things there. So let's see, it would be a 2-dimensional char array, and I will initialize it in the constructor, and rows and columns there. And this will now break a bunch of things because we are printing the null characters. We need to initialize it here in the constructor. that will let us do so. And I think I will extract this into a helper method. Like that. Okay, now all the tests are passing. And actually I think I will refactor this. Into its own method. So that this now better hides the details that what logic determines the color of each sector. Yeah, well, that's a bad name. Then now let's unignore this, and now we still have that it moves. So on. No, it disappears. But we can do this kind of trick now. Like so. And that made it pass. We will need to refactor this first though. Let's see the time. Commit that previous one. Okay, yeah, well, whatever. Skipped that. Committing this separately. Okay, now let's refactor this a little bit. Now we have a bit heavier application here. That one there and that one there. Those have the same semantic meaning. So we replace them. Then this is starting starting to move in a single, that these all belong logically together. Let's see. Should I maybe move that information? I might want to move these fields inside the block or at some point, or at least, and probably at some point I will create a value object which contains both the coordinates, the row and column. But maybe I will still wait a little while before I do that to see how the code progresses. Then let's see what is the next test. So when a block lands on another block and we have the code that okay, we drop a block and tick it 3 times, now it should be on the last row, and stop there. This is because this is a very complex test setup, we want to make sure that our test is initialized into the correct state. So I expect this one to pass. It's a part of the feature that we just implemented before. Then after that, we are now interested that we have a second block and we move it down 1 stop. It should be there. So it should still be falling right above the other blocks. So basically the same as here. We can still move it. We could still move the block left and right and avoid hitting that one, that X. So this should pass. Why it did not pass? Okay, now I think now I understand. We may put a debugger in here. I can show you that. See where's the console. Now it's on that state. Then we drop a block, and then it's already before this tick is called, the new block starts at that location. So we need to reset that. When we drop a new block, it should start from the beginning. So let's see. And I will also move this to the constructor. Or this method for symmetric reasons. Okay, and now the test is passing the way we thought it should pass. Then this last step, it should stop and this should fail. Yeah, now it moves on top of the other block, hiding it. So let's see. Here in this tick we need to detect whether it would collide with another block. And let's see how to do this. Yeah, well, I think we can hack it in here. If falling block row plus 1, and if that spot is not empty, or if it's empty, then we do that. Otherwise, well, let's do nothing for now. And that lets us get past this first assertion, and then it should stop moving. So basically the same thing as here. Like that. Okay. Now I realize, okay, it needs to stop right where it is, like so. And now we have a really messy code, but let's first commit it and then refactor. That makes it easier to roll back to our previous state. Although in IntelliJ idea here is a local history, and I could here revert to any previous state or undo specific lines, even without version control. But depending on what editor you are using, you don't have that ability. So I recommend doing commits often, depending on your confidence of not messing up. Then let's clean this up. Really obvious falling duplication in here. Let's extract that into a method. And these two, let's see if we can combine them into a one. See, everything should still be passing. Let's see, where is the flip? Okay, well, that didn't work out. Let's see, why did it not work out? Right index out of bounds. Okay, it's sticking there, and oh yeah, okay. Well, that should make it work. But that's not really making it any clearer. Well, let's extract some of these. This is that it hits the floor. And then let's see, if I would negate this one, then it would be that the check is that it hits another block. Let's see, let's swap this. Okay. And now those two are okay. Let's merge them together. So, okay, now we tick, and if falling hits the floor or the falling hits a stationary block, then we stop falling, and otherwise we move it downwards. Yeah, well, I could still extract this. Fall one step or fall one row. I think that's better, and let's order these so that they are in the same order that they are called from this higher level method. Okay, and I think for symmetry with the stop falling, this I will rename to start falling. Let's see. Let's keep them side by side like that. And these are maybe more important than these, or likewise these three relate to each other. Then let's see, I think these are also a bit low level methods. Let's move them all here. But this one relates to that, so let's keep it there. And oh well. Oh well. Let's keep that there still for now. It's more related to printing than this logic. Okay, I think that's it. Is now cleaned up. So the code is now as simply implemented as possible for falling just this kind of single blocks, and I can't think of any more tests to write, so next time let's start implementing another feature. Thank you for watching, and see you later.